Hey Pre-Calc! So these are your 1.5B notes for solving equations. To start with, I wanted to talk a little bit about solving an equation that had a radical in it. So we saw in class today that the first thing you need to do is isolate the radical, which means I'm going to get this root 2 minus x all by itself. To do that, I think I'm going to add it to both sides so that it comes over here and becomes positive. And then I'm going to take away 2x from both sides. So I'm going to get a 1 minus 2x. As soon as you get the radical isolated, you're going to just square both sides. So when I square a square root, this guy's just going to cancel out. And on this side, I've got to remember to FOIL to expand this binomial so that I don't just square both things on the inside. You guys are getting really good at recognizing that red flag of death. When I FOIL this out, I'm going to get 1 times 1 is 1. Let's see, I get a negative 2x, and a negative 2x is a negative 4x. And then I also get a positive 4x. Now I need to collect all of my terms on one side so that I have 0 on one side. So let's see, I have 4x squared, I'm going to write that first. And if I add x to both sides, negative 4 plus x would give me negative 3x. And then if I take 2 away from both sides, 1 minus 2 is negative 1. Okay. It's probably going to be fastest to try and factor. This guy might factor, I'm not sure if it does. And one trick, if you have any troubles with factoring, is you can, in your graphing calculator, plug in the equation. So 4x squared minus 3x minus 1. And you can use your graphing calculator table to find a 0. Ooh, second table set, start at 0 because my table's all screwed up. Okay, so right here where it says x equals 1 and y equals 0, this is a number that when I plug it in will give me 0. It's one of my solutions. Well, if x equals 1 is a solution, then that means x minus 1 equals 0 was one of my factors, kind of working backwards. So I know that this has to have an x minus 1 as a factor. Now, if that's the case, then this has to be a 4x, because 4x times x is 4x squared. And if this is a minus 1, that means this probably has to be a plus 1. So let's double check. This gives me, let's see, 4x squared is good. It gives me a plus x and a minus 4x, which really does give me the negative 3x in the middle, and I do get a minus 1. So you can use your calculator to sort of get one of your factors for you, which is nice, by working backwards. Now, let's see, 4x plus 1 equals 0. Let's get the other one. So that means 4x equals negative 1, so x equals negative 1/4. It's really important anytime that you solve an equation that involves a radical that you check for extraneous solutions at the end. When we squared both sides, we might have introduced a solution that doesn't actually work. And so if I were to go back to my graphing calculator, I can hit graph and hit zoom 6 to just zoom it in standard. I get a parabola here, and that's all I have. Oh, you know why? Because I only plugged in a part of the equation after I'd worked it out a little bit. If I want to use my calculator to check the original problem, I should plug in 2x as y1 and 1 minus the square root of 2 minus x as my y2. And now I want to see where these intersect. So there's 2x, it's a straight line. And there's 1 minus the square root. And if I want to find the intersection point, I'd hit second calc, intersect. Enter, enter, enter. And I get the intersection that happens at x equals negative 1/4, y equals negative 1/2. And so it turns out that the only actual solution to this problem is x equals negative 1/4. X equals 1 doesn't actually work. Another cool way to check this, another cool calculator trick, you can store answers as x. So there's this key down by the on button, the store button. Okay. And on my calculator, I could type in negative 0.25, because that's negative 1/4, was one of my answers, and then hit the store key, which will give you an arrow, and then hit x. Now, anytime I do something with x, my calculator is going to think that negative 0.25 is x. So then I can just type in the original problem, 2x, and see what it comes out to, and 1 minus the square root of 2 minus x. And lo and behold, they come out to the same thing. Now, one of the reasons why I think this is so cool is that I can then say 1 store x, so I can change it to the other solution, enter that in. And now by hitting second and then the enter button, So do you see this enter, like right above it says entry? Okay. What I'm going to do is I'm going to hit second and then enter. And when I do that, it brings up the previous lines in my calculator. So I don't have to retype this 1 minus root 2 minus x up here. It's plugging it in again for me without having to retype it. But now it's telling the calculator that x is really 1. So when I hit enter, I'm going to get something different. And then I can go second enter, second enter, second enter, and second enter until I get back up to 2x and hit enter. And do you see I get two different answers? Well, that tells me that x equals 1 is extraneous. So, sorry, that was a lot of calculator tricks. You might want to write the steps to those calculator tricks down or rewatch it a couple times to make sure that you get it. Now, the next type of problem that we looked at today in class was solving a quadratic type equation. These are equations that have 3 terms. That's usually going to be your dead giveaway. But they're not quadratics because they're not to the second power. They're not to the second degree. So in this case, I think u substitution is usually pretty helpful. So I'm going to say let u equal x squared. The shortcut is you always make u be the middle term. And then in that case, this would become u squared, because if I were to square both sides, u squared, when I square x squared, I would get x to the 4th. And then this would be minus 8u plus 8 equals 0. Now, if we could factor this, we should. I can't think of 2 things, though, that multiply to 8 that add up to a negative 8. Because I'm thinking 2 and 4, that's going to make like 6 or 2. 1 and 8 is not going to work. So I don't think this guy's going to factor. Which means I could complete the square, or I could use the quadratic formula. Now, since it has a middle term that's even, I'm going to complete the square. So u squared minus 8u equals negative 8. I move the constant term over. And then I'm going to take half of 8. Well, let's see. 8 divided by 2 is 4. And I square it, so I'm going to add 16 to both sides. Now I'm going to factor this. It's going to factor as u minus 4 and u minus 4. So that's really u minus 4 squared. Oh man, my 4's and my u's are kind of looking the same. I probably need to write those more clearly. And over here, negative 8 and 16 make a positive 8. So now I'm going to square root both sides. And I get u minus 4 equals plus or minus, let's see, root 8 is really 2 root 2. And then I get u equals 4 plus or minus 2 root 2. Now, the only trick when you use u substitution on a problem like this is that you're going to need to go back and actually solve for x. Because this original problem asked us to solve for x, but we really got u. And so, let's see, I'm going to need more space. So I'm going to come over here. Sorry guys if you're following my, hopefully you left room there for yourself. So really, x squared is equal to 4 plus or minus 2 root 2. And so then we would square root that, and we would get x equals plus or minus the square root of 4 plus or minus 2 root 2. Now, this looks like all sorts of crazy. So, you should probably separate this out into 4 answers. I'm just going to put that out there. To do that, I would take my calculator, and I would go, let's see, the square root of 4 plus 2 root 2. Let's see, I open parenthesis, so I need 2 closed. So let's see, that gives me x is approximately 2.61. And then I can hit second enter to pull that back up and change this to a minus sign. And I get 1.08. Okay, but since it's plus or minus, I could also have negative 2.61 and negative 1.08. Because I was taking the positive square root, I could have also done it with the negative. And this is good, I got 4 answers. The reason I say that's good is because it's a 4th degree polynomial, so I should have 4 answers. And I'm going to box those guys. Okay. So then the last problem is another quadratic type. It's quadratic type because we've got 3 terms there. And so I look at the middle term and I'm going to make that my u. U equals x to the 1/6. This is just an extra practice problem, really. Quadratic types, if I were to say u squared, I would be squaring x to the 1/6. And when I do that, I get x to the 2/6, which is really x to the 1/3. So this x to the 1/3 here really is u squared. And then as soon as you do u substitution, the problem looks a lot more like what you'd like to see. This is going to factor, I think. Let's see, a -2, so I need one thing to be a -2 and one thing to be a 1. Does that work? Oh, this needs to be a +2 and a -1. And then u and u. So then I get u minus 1 equals 0, so u equals 1. U plus 2 equals 0, so u equals -2. But then, just like last time, we're going to have to go back and substitute x to the 1/6 in for each thing. So x to the 1/6. Now, in this situation, the 1/6 power is like the 6th root. And the way I cancel out a 6th root is I take the 6th power of each side. So I would get x equals 1, because 1 to any power is just 1. And then here, the 6th root of x equals -2. Now, I'm going to go ahead and answer this out, but this should be sort of an extraneous solution red flag for you guys, because there's no way to take an even root and get a negative number. So anything we get out of this is going to be bad. It's going to be fruit of the poisonous something, whatever that saying is. I can't remember. Anyway, so when I take this to the 6th power, let's see, 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64. So had I grabbed my calculator, this would tell me 64. But now if I go back and check my work, let's see, so I'm going to say 1 store x, and then I'm going to say x to the 1/6 power. By the way, notice that I'm putting 1/6 in parentheses, otherwise it doesn't know that the entire thing is the power. Oh, sorry, 1/3 power. And then plus x to the 1/6 minus 2 comes out as 0, which is what we wanted the original problem to come out to. And then now if I store 64 as x, and I hit second enter, oops, second enter, second enter, second enter, there we go. And notice it doesn't come out to 0 like it was supposed to. The problem was supposed to come out to 0. This comes out to 4. The reason is that right here we introduced an extraneous solution. So x equals 64 doesn't really work. The moral of the story is go back and check your work, people. All right. Have a good night, and I will see you tomorrow in class.